Well, hi, good morning. Thanks so much for joining me here in my shop on December 28th, 2022. Just a couple days left of this year. There on my bench is a little tiny radio. The last radio I did was a big one. This is a little tiny one. Now, if this is the first video of mine you have watched, if you're new to my channel, let me just explain a little bit about what's going to happen here and what's not going to happen. First of all, what's not going to happen is I'm not going to teach a lesson on how to repair radios. I'm going to just attempt to repair this one. Now you can watch and you can learn from me what you can. And some of the things you can learn from me are the wrong way to do things. I'm not here to show you the perfect way to do this. I just fix lots of radios and I have my ways to do it, and that's what I do. So sometimes while I'm working, I'm talking about, well, almost all the time I'm talking about what I'm doing. Sometimes I say things that in the end aren't true, that turn out later to not be true, or I'll make a misstatement. I won't realize what has come out of my mouth, and I've said something wrong without realizing it. So often I say you need your thinking cap on when you watch these videos. Okay, having said all that, here's one of the smallest radios I've seen. It's just a little guy here. Oh, a little information on the bottom. As usual, I don't know anything about this radio other than one of my friends gave it to me and said, "Can you think you can fix this one?" It's an Arvin, A-R-V-I-N, just a single band AM radio in a metal cabinet, which is really unusual. This one, well, it certainly is worn out here very, very badly. It looks repainted, but I can't be sure. Who knows what's been going on with this radio, where it's been all its life, what its journeys have been. It's here now, though. It's a yellow sticker, so it was probably sold at a yard sale or a flea market or something like that. To change tubes, remove these two screws, and it looks like it says take off back. That being the back. It has an antenna hanging out here, so it has no antenna of its own. I guess on being in a metal cabinet, you couldn't really place an antenna on the back of this. This is metal too. Very odd. It's just totally wide open here. You'd think they would make the cabinet come right up and then you just vent it instead of leaving it open like that. Okay, it has a plug on it. It's a non-polarized plug. Looks like it's probably the original cord. Let's just take a little inspection here. One of the things about my style of radio repair is I like to get the radio operating as quickly as possible, having done the minimal amount of work to it. Sometimes no work at all. I'm plugging these guys in, finding out that they work to some degree. And the reason I do that is I'm looking for cracks right in here. Put your hand here, a little bit of exposed conductor. That's one way to find out. The other way is to inspect it a little bit. I also don't finish sentences. Have you noticed that one already? Okay, well, I'm not going to plug this straight in and turn it on. I think probably the smart thing to do is to take it out and take a look at the condition of it before we do that. Okay, this feels normal. All feels normal. Let's see if we can pull this knob off here. And the answer is no, because it's screwed in, Jim. Just a little flat screwdriver. So just like everybody in North America, we've been having some wild weather here. There's a couple or 3 feet of snow outside. But we have not had an unfortunate amount of snow or something like that here. But lots of snow here. So, the square head screws here. Square head screwdriver. The square-headed screw, which we call the Roberts screw, is a Canadian screw. I don't know if you can really see that it has a square That's unusual, apparently. In the world, here in Canada, it's not unusual at all. Everything is done with these square head screws. Especially furniture and anything with wood. That's why, because you can do that. Okay, small lesson on Canadian screws. There we go. Oh my gosh, look at that. Somebody's been through this whole thing already. Oh my gosh. What a surprise. I was not expecting that. Well, let's take a look. Let's take a look at it. See somebody else's work. Well, it's a fine looking job at a glance. And looks like something I would do, actually. Did I do this? Does this radio come through here and I forgot about it? And it's come around again? Well, it looks to be in great shape. I don't think there's any reason not to plug it in and give it a try. So why would my friend give me this radio if it's working? Maybe he's afraid to plug it in. Okay, a couple things to observe first of all. Condition of the speaker. The hole through here. Some kind of stain here on it. Don't really know what I just proved. Looks like some stuff has been spilled down through here. A little rusty in here. Nothing on the cabinet that suggests that. Well, actually, if you look through this hole here, you can see it looks like something is poured in and collected down there. Who knows? So, speakers probably okay. They usually are. Two capacitors directly on the knob, so there's no string in here to break. Okay. This radio has all of 4 tubes in it. It's a 4-tube radio. It must have a rectifier diode, I guess, in here somewhere. Let's see if we can spot it. We take the power cord. This will be out of there. Oh, just going straight over to this tube. This is a rectifier tube. Wow, this is an unusual radio. So it has a tube for a rectifier and then just 3 more tubes. This one has to be the output tube. Usually you're looking at a 5-tube radio, not a 4-tube radio. That's how they managed to get this guy so small. Up here is the antenna coil. So the antenna wires coming in and connecting right here. I see the last fellow has left the mica capacitors, which is also my style, if you like. And under here there's more mica capacitors. Now the last radio, here's a big one here. The last radio I did, I discovered some of these mica capacitors were shot in that radio. Here's something else that's worth noting right here. So this kind of unusual looking piece of wire that's looping up and down here. It has a black paint mark right here, which might indicate something. I'm pretty sure this is actually a resistor. This is a technique for building a high wattage resistor, or a higher wattage resistor. Talking about resistors, this one looks new. This one could be new. Somebody's done a lot of work on this guy. This is the cord grip is broken here. That's a It's a hint the cord has been replaced. But it also looks like if you pulled hard enough on this cord, like if you swung the radio around by the cord out here, maybe it would pull enough to tear this cardboard piece. Okay, nothing too. I'll almost put my finger through the speaker. Well, I think we got to plug them in. We got to plug them in see what happens. I don't think there's much risk here. Now, I have a way of plugging things in, so if there's a short circuit or something seriously wrong with the radio, nothing really bad will happen. So just beside the wooden dolphin, or behind the wooden dolphin, are a couple of light bulbs. And I'm going to feed the power coming to the radio through those light bulbs. In fact, just through one of them. So this is my bench power unit. It's just a 2-prong extension cord, even though it has a 3-prong thing here. 1 prong going nowhere. This is plugged into an isolation transformer through this, which is also an isolation transformer. Why? Sometimes there's not a lot of reason to what's going on in here, okay? So excuse me. Plug this in. You have a little switchboard up here. This silly thing here. Turn this on. Power is ready to go. To go where? If I throw the switch downwards, it goes through the light bulbs and out to the radio. If I throw the switch upwards, the light bulbs are not involved. So the whole idea is, if there's a short circuit in here, something terribly wrong, when they apply the power through the lights, the light will get really bright as the power is being drawn through it, and that will alert me. Sometimes I'm not so alert. Alert me to something bad is going on. I can stop, I can cut the power and deal with it, rather than rely on my house circuit breaker, which would not be too good a thing. Okay, so well, there's if you could take more steps towards building up power in the radio. I could pull out the rectifier tube and power it up, stuff like that. Usually, you have a 5-tube radio. The voltage drop of the heaters of the five tubes adds to 115 volts or something like that. And all these tubes are purposefully selected tubes. They all work with the same current, so you put them all in series. Same current going through all of them, and you just basically plug them into the wall and let 120 volts or 115, whatever's coming out of your wall, heat your 5 tubes. But this radio's only got 4. So how's that work? Now we got 120 volts dropping across 4 tubes. How can that work? This one is this looks like a 50 L5. These two are probably 12 something or others. Something else I usually do before plugging in a radio, I've kind of convinced myself to do this, is to make sure the right tubes are in the right spot. Once in a while I get a radio and not just are the wrong tubes in the wrong spot, totally wrong tubes in the radio. 12 SQ7. Okay. So I got a 12. This one over here is going to be a 12 also. This other one. And this guy would normally be something like a 35 Z5 or something like that. Let's see what it is. Let's see what it is. What is it? Uh-oh. Oh, it's a tube without a label. Oh no, there it is. I can see it. 35. Yeah, 35 Z5 is what this is. So if we add up 12 and 12 and 50, it's 24, that's 75, and then 35, 75 and 35 is 110. So 110, but sometimes I got more than 110 coming here. So they may have taken steps to drop some of the voltage across a heater, across a high wattage resistor, and that could very well be what this wire is. This wire could be kind of in place of the 5th tube. Or maybe they just let it have it. I don't think so too. Look at this. Now here's a really good sign of something being dropped into the radio. Something very corrosive. What would that be? Some kind of cleaning fluid or something? Not a good sign for the speaker. Okay, any more observations? So one of the rules I've discovered, this is a general rule in life, is the longer you look at something, the more you see of it. So often at this stage of things, I drag my feet a little bit so I can spend more time looking at this stuff to try to spot interesting things. So here's an interesting thing. This side of this transformer is riveted, but it's riveted to nothing. It's loose. This side has a nice shiny screw driven into it. Well, what's going on here? This looks like a replacement. And not necessarily one made for this radio. Maybe this is a junk box replacement. That would mean, I can see some soldering here. The other thing I noticed about screws, what else? I noticed something else about screws. It didn't say anything. Oh yeah, these two screws. Well, look at these ones. These are high security screws. These aren't your ordinary run-of-the-mill screw. Why would they have this type of screw here? So I'm thinking maybe what's happened here is this speaker's from somewhere else. That's why it's stained and the cabinet is not similarly stained. Pretty much a long shot to get a good replacement. To get this coil would have to be luckily fitted onto here. Well, we don't know. And it looks like it's exactly the right size and shape of speaker. I don't know. Curiosities. I like to make as many observations as possible before I set it on fire. Okay, so we're plugged in here. Now, how about this? We'll switch this off, and we're going to apply the power, and hopefully nothing will happen. Now you can see there's a bank of voltmeters staring back at you in the background here. So this guy is showing the line voltage right now because I pushed this button. 119 volts coming in. This one shows the output from here. It's a little higher because I cranked it up during the last project, so I'm going to set it to roughly 117. That's the voltage coming out here. This cord is going into this panel, is coming out into here. Just trying to explain a little bit so you can follow along what's happening. There are safety issues with doing this that I'm not talking about. I don't like to talk about safety stuff too much, other than to say, if you're doing this kind of work, especially with a radio like this one, let's check something else out here, come to think of it. Thank God I delayed this. If you're working on a radio like this one, you got to understand something called the hot chassis problem. So research it on the internet. Make sure you understand it. It's trickier to understand than you might think at first. Hot chassis problem. Now, what kind of problem does this radio have? So if we follow the power cord, one leg goes here. I do not have power supplied to this, okay? So I would not be sticking my fingers in it. In fact, let me just flip that off just to be sure. In fact, I generally have a policy to keep a radio unplugged. Let me implement the policy. In case my supervisor comes by, sees me doing that. I mean, once you unplug a radio, there's no question that it's dead. So what I'm looking for here is there any connection between the power and the chassis? Well, here I see something interesting. I see this capacitor with a resistor across it, going to the chassis, no question there. Coming from this point, seems like a popular spot in the radio, a lot of stuff hooked up to it. You can see a wire coming from the back of the switch here to the popular spot. So we can start calling this spot B minus if we want. And it looks like in this radio, excuse me, the chassis is isolated away from the radio electronics except for the connection made by this capacitor and this fairly large resistor here. Looks like it's 220 1,000 ohms. So important to see that. What would make my it wouldn't make my hair stand on end anymore, but would excuse me, make this whole thing a little more dangerous, I guess is the word, is if there's a direct connection from the power line straight to the chassis. And if the radio makers are using the chassis as the B- line in the radio. Because the plug is non-polarized, it's a 50-50 gamble which way you plug this in. Read up on the hot chassis thing. This one, I'm going to call this a warm chassis. Last long look at it. Still all looks okay. Well, I have a cup of coffee waiting for me, so let's get on with it. Switch is off. Oh yes, I was going to say this bank. Yes, here we go. Again, if you're new to my channel, this is my cat. That's my cat Peanut, and he comes in just about this time every morning and says, "Come spend time with me." Is that right? Can you wait just 2 minutes? Peanut, Peanut, Peanut. 2 minutes. 2 minutes. We've got to hurry now. I got a cat waiting for me and a cup of coffee. There we go. So you'll hear this switch click. What you want to watch is this meter. These lights in particular. In fact, I'm going to unscrew one bulb here. Pardon me, fish. How do you like that, eh? Isn't that something? So we're just going to rely on one bulb. One bulb. It's not that the power goes. It's not that the power goes through one bulb then the other. They're in parallel. They're in parallel. So I just removed one. So now there's only one bulb working here. All the power that gets to the radio goes through the bulb, and we should see nothing happen here. Except you saw this meter pop up. This meter is showing the voltage. Peanut, please. Just hang on. I said 2 minutes. It's only been 1 minute. There's still another minute. Okay, he's thinking about that. Now this very accurately shows the voltage at the plug. 109 volts. Why it isn't 117, I couldn't tell you right now. Excuse me, there's literally no current flowing through this except to power this little box. So we would expect this to be a little higher. 109 is fine. Most radios will operate with 100 volts. I'll put that where you can kind of see it. And now, when I hit the switch. So, I'm going to cut the power off. Turn the set on. This time, Peanut, just come on. 30 seconds now. I'm going to hit the power here. This meter may not come up. This light should come on briefly, and then it should dull down. And then it should come on brighter again, and when it does, and it may not be bright enough to even see in the camera, but when it comes on brighter, the radio should start operating. Volume is up a little bit. 3, 2, 1. Got a bright light. It's going down. It's going down. It's slow. The voltage is only 43 volts. That's not nearly enough. The fact that this is happening indicates the tube heaters are operating. I could see one tube heat up, so that's another indication. If one heats, they're all heating in the series tubes. It takes a long time to warm up with this kind of restriction. We're only 66 volts on the radio. Nothing funny happening, no smoke, no sounds. Just a cat, that's all. Turn it up, but here it comes, even with 65 volts. Okay, that's full volume now. We'll turn the volume down. Now screw in the other bulb. That's going to raise up the voltage here. Quite a ways. Voltage is now 100 volts. Okay, Mr. Radio. What's the matter with this radio? pretty quiet down in this area. Dirt in the capacitor a little bit. It certainly is receiving. Okay, that's good for now. I'm going to stop for a bit. Make my cat happy. Oh, he gave up on me. He gave up on me. Make my cat happy, drink some coffee, and then we'll come back. Do a few tests and see how well this is working. See if I can pick something up with it. And then we'll look at, I guess, jumping straight to alignment. I don't know what else I can do to this. This is a far cry from what usually happens in here. Usually what happens is I have a great plan to go forward on a radio. I get one step into the plan and everything goes awry. And from there it's quite a ride all the way through the repair process. But maybe not with this one. Okay, back from a catless coffee break. My cat, he didn't want me, he wanted food. Okay. These wires go to an outdoor antenna. I'm going to use this one to apply an antenna to the radio. We're going to see what we pick up. It's got this big bundle of wire, but I'm in my house. Is my house any different than your house? It's full of all kinds of radio interference noise sources, which are particularly brutal on the lower frequencies, like AM radio, pretty much wiping it out, really. Sometimes when I'm out in my car, I'm sitting in a parking lot, maybe my wife is in getting something from the store or something like that, I'll tune through the AM radio. I almost get tears in my eyes because my car radio on AM can pick up all kinds of stations all day long, all over the place. But in my house, I'm lucky if I can get one. I don't bring my car in my house. Radio's in my house. I'm lucky if I can get one station. This is how I basically judge radios. If it gets one station at 590, then it's working, but it's minimally working. If it can get 3 stations, it's doing really well. That's about it. Yeah. But if I took it outside, and I've done this with radios, take them outside on my deck in the summer or something like that, and presto, they pick up all kinds of stuff. So that's a big problem with the inside of our houses and AM radios. And besides, who is listening to AM radio anyway? Somebody must be. Because there are thousands of AM radio stations in North America. Okay, so we're going to plug this guy back in. He is plugged in. We're going to turn him back on. There he goes. Okay. And let's just take a look at the tuning here. The low end is over this side and the high end's over there. It's kind of backwards from how I would think of it. The low end is where the stations are. Can we get, with this bundle of wire, can we pick up anything? Okay, so this is typical interference sounds in my house. Ooh. Okay, I know what this is. This light. See? Told ya. Okay, it's not the light. Okay, it'd be a mystery as to just exactly what's causing that. But wow, that's bad. So, but can we hear a station through that? How could it possibly come through? So that sound is a typical noise sound I hear in my house all the time. That sort of rumbly sound. So I think the radio is receiving. It's just not going to be able to receive anything but noise. So we're just going to leave this out of the deal here. I might have to remove this in the end because this will be picking up all the noise here in my shop. We'll click this outside antenna on and we'll just see if it makes any reasonable difference here. ground side, I could clip this onto the chassis. You can see what happens. I will do that. Before I do that, I get out my voltmeter and just check a few things out. Now right now the radio is plugged into an isolation transformer, so this is a somewhat goofy thing I'm doing. But better to be surprised by the reading on a meter than the burn mark on your finger. Okay, here we go. Got this on DC. AC. I'm going to ground this other lead and see if there's anything there. There's nothing there. There shouldn't be, but I'm not going to stop here. I'm going to take this, pull it out of my isolated outlet. I'm going to plug the radio into a regular outlet at this point. And we'll see. We'll see what happens here. Now this is a 50-50 plug-in because it's an unpolarized plug. Okay, I turn the power on. Give it a moment. Now this time we're really going to find out a couple things. I wouldn't be surprised to see a reading here. Nothing. Oh, that's because look what I've done. Look what you've done, Jim. Okay, onto the chassis. Not onto here. Onto here. Did I do that other test wrong too? Probably did. Here we go. Ooh, 113 volts. Ooh-wee. Let's reverse the plug. Zero. Now the thing about the 113 is the amount of power that can be delivered through the chassis into my meter may be very, very restricted, but may be more than enough to operate the meter. Because the meter requires very little current to operate, very little. So it could be I get the full voltage, but really, if I put my finger on that radio, which I just did, and mind you, I'm standing on rubberized sole slippers here. I'm triple insulated from the floor in my shop. Not to say I couldn't have my other hand sitting on something, grab this guy and find out for sure if there's 113 volts there. Chances are the amount of current that can be delivered is very, very restricted. So chances are the most I would feel if I put my hand on the ground and then touch that chassis, which I am not going to do, I would probably feel a tingle of a milliamp or two, not too much, flowing into me through that resistor-capacitor combination I pointed out underneath the chassis that's soldered to a chassis lug. That's kind of the idea there. What's going on is that they don't want this chassis to just be a piece of metal sitting here not connected in any way to the radio. That will cause problems. At the same time, so they want to connect the chassis metal back into the radio where it will nullify any problems that are developing, radio type problems that are developing because of the chassis metal sitting there. But at the same time, if you do the simple thing, you just connect it to B-, you've then introduced a very serious hot chassis safety issue with a 50-50, but actually it's 100% risk on it of getting a shock. 50-50, 100%. So what they do then is rather than use a solid wire, they use the capacitor and resistor combination, which provides a sort of a filter which is enough to quell the radio problems that may occur from a floating chassis while restricting the amount of shock current that could flow from someone touching it. And I mean, this radio is in a metal cabinet, so what are the chances you won't touch the chassis in this radio? Zero. You're going to touch the chassis in this radio. And I'm surprised, a little bit surprised anyway, the fellow who worked on this didn't switch the plug for a polarized plug. With a polarized plug, it's only going to go in the outlet one way, and you can set the radio up so it's this way with no voltage between the chassis and ground. That is what I measured, right? I did measure that. So here's what we're going to do. I'm going to measure it again just to double check. Not with that scale, with this scale. See, I did say something about making mistakes, right? So see, there's nothing there. And if we look between the chassis and this is the same thing. This is just rounded. We see nothing. Now I still have this plugged into a regular outlet, which is not normally what's going on my bench here, but I should be able to hook this up to the ground without fear. Okay, everybody, look away. Look away, because there's always a little bit of fear there. No, nothing happened. What if I turn it up? Oh yeah, wow, wow, wow. So I believe what's happening is the signal on the antenna, which the ticking you're hearing is probably coming off the antenna wire here, is simply improved. So if we go, let's go away from the ticking. If I hook it up now. Wow. What is that causes that, eh? Can't beat that off. Holy smokes. Yes, I've gone searching in my house many, many times to try to find the sources of these noises. And I have been successful occasionally, but there are so many sources, and they are spread throughout my house and your house too by the power system, because they get onto the power wires in your house. They go everywhere. And that gives you a very complex array of noise signals all over your house. If you do the small radio runaround thing, you know, where you get a small radio like this, turn it on to AM, maybe a million, right in the middle of the AM band, same noises there. You run around your house, you'll end up finding it everywhere and nowhere. Occasionally, we had the power out here. I guess it happens to everybody now and then. This is back in the summer. The power went out for about an hour and a half. I had a chance. I thought enough. Hey, nothing else to do. Let's turn on an AM radio. And it was like being in my car in the parking lot here in my house. It was just so upsetting to realize how much is just being washed out by noise on these radios. Okay, so if it's not going to pick up a radio station, how am I going to judge if this radio is working reasonably well? I'm going to use my own radio station. I am going to start up this guy here, a signal generator. My family has a Swedish background. Swedish history. Actually Finnish. Actually Finland. My ancestors lived in Finland, but the Swedish-speaking part of Finland, and I believe a culturally Swedish part of Finland, they don't know much about it. But, okay, well, I just keep going here. Let's just keep going here. Inside this little box is a capacitor just to provide more isolation between the signal generator and my projects, specifically for that chassis voltage thing and stuff like that. And the radio is still plugged right into a regular outlet. We're sending a signal at 1590, but we want to be down more around the middle of the band. Let's go down to around 1 million. Okay, and I'm just going to calibrate this 10 times, so it's 1,000 microvolts here, roughly. So here is something like 1,000 microvolts. That's a pretty good signal. Any radio should respond to that. And I will connect first the ground. Yeah, look away, put on your flash glasses, look away. Oh my gosh. How's this going to work? As soon as I apply the ground, away she goes. Okay, alternate. We won't actually connect this. We will try to induce the signal generator signal into this hapless bundle of wire here. Let's see what we get. I'm going to actually short this right out. We'll see if we can get any signal into it. So we're up around 1 million. Million's going to be somewhere around here. I've got to jack the output up here. I need modulation. Maybe 1,000 hertz. Sorry, I keep reaching across there. Can we find this? Millions up this way. Well, that doesn't help. There's no pointer on the dial. Well, I guess I can use the wheel. Right in here. Now, there's stuff there, but is that my signal generator? What we'll do is we'll put this around where 1 million should be. And I will tune the signal generator and attempt to spot it that way. Nothing. Okay, we'll put a little more output. I have maximum output coming out of here now. Let's see, can we find it? It's just possible the radio is tuned too low. Let's go up here a little higher. This would be, according to this, around 1300. Most radios would respond to this kind of thing. No response. No response. Okay, so what we'll do is we're going to send over to the radio a signal at a frequency of 455 kilohertz. That's a guess at what the IF frequency is. I just noticed there's only one IF transformer in this radio. So 455 is the guess. See if the radio responds to that. Now I'm just kind of pumping it into the antenna wire here. It's not a very great way to connect it. Let's just check our output level. Okay. So this should say 455. We should hear something. Nothing. Not a thing. Okay, so we want to more powerfully inject the signal generator signal. I'm going to turn it down. I'm going to stick it. I'm going to ground this. No, we won't. First, yeah, I think I better ground it. I'm going to ground this. Holy smokes. I'm going to put this here. What can we do now? Up here. 455. Aha. We have something. Let me just turn down the machine gun here. Now I'm pretty sure that's interference coming from outside the radio. Let's be a little more sure. Turn this down. Oh, don't hear it here. There it is. Sounds more like a helicopter on this radio. Is it coming out of this radio? I'll turn the power off to it. So this radio's dead. No, it's not, Jim. It's plugged in the outlet. Hold on. A little mistake there. Let me pull the plug out. Well, that was pretty interesting. the land of unexpected results. How come the hiss went quieter on this radio? How'd that happen? So make sure this one, we can't hear the tube one, the volume's right down on it. I'm going to pull the plug on this radio, and the hiss is going to reduce on this one. That's odd. I don't know what to say about that. But you could hear the ticking anyway on the much better radio. This radio, the 5-tube radios, or in this case the 4-tube radios, these are very susceptible to these kinds of problems of noise and stuff like that. They're very poor radios, the only way to describe them. Really intended for strong signal reception, back in 1952. When there wasn't, everybody didn't have a computer in their pocket. So what can we try next? Turn this up. Okay, we can hear the signal. What frequency is that at? 143. We'll go up to 155 here. 455 rather. 4. Dead. Interestingly enough, the speed of that ticking just almost seemed to double there, didn't it? The other thing that's interesting about this ticking is when it starts, it'll start slowly. Tick, 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 tick. It'll speed up. And when it finishes off, it'll just start slowing down, tapering off, and then finally just be gone. What the heck is it? Sometimes I think it's static discharge coming from somewhere, but I got no way to explain it. It's nothing to do with my furnace fan. I have investigated that already. Odd stuff. But the key thing is we can hear the signal from the signal generator at close to the proper IF frequency, getting through the radio, coming out the speaker. So now we know a whole bunch of stuff. We know basically the radio operates beyond the IF. It looks like it's tuned or has not been tuned properly because it's at 440 here. And it should almost certainly be 455. And that's not too surprising. Even somebody who has the wherewithal to do all that capacitor work may not have in their shop the equipment to do a proper tune-up. And they may have done an ear tune-up without equipment. And so they just kind of adjust things until stuff seems to be working, and then that's as good as they can get it. So, but I've got instruments here. We can do a little better job on this. We could even do it right now, in fact. Well, okay, let's do it right now. Why stop? So I get myself a screwdriver. And what we're going to be doing, we're going to adjust this transformer. We're just going to do it by ear, but I'm doing it with a proper signal generator over here, which you can't quite see, but that's okay. Is this going to fit? Yes, it will. Okay. Start up. Now we want to get to 455 with this. Before I do it, there is a chance that this has been tuned to where it is, 440 in fact, on purpose to try to compensate for other tuning issues in the radio, particularly to get the dial to come up in the right spot. But if someone's doing this without instruments, they don't know what frequency they're actually adjusting this thing to. And that's how it could get off. So first I want to change my signal generator. I wish the ticking wasn't there, but I can change my signal generator in the direction I want to go until I can barely hear the tone. Barely hear it. You know what I'm going to do here? I'm going to make this easy. I'm going to put more power out. Go further. I'm really sending over a blasting signal. In fact, you know what? That's 455 coming through. You can see on my frequency counter. I can still hear it. Now I just have to pick this up volume-wise. This will be easy. This is easy radio. Just by ear. Okay, it did make a lot of difference. Now, the next thing we want to do, kind of have to put this guy back in the cabinet. We're going to want to, well, I can tune this, actually, you know what? Maybe I can, well, I think the pointer will line up perfectly with the edge of the capacitor here. So I think I just use the capacitor edge as if it's the pointer. So if I want this to be tuned to 900, I'll put this straight up. That looks to be straight up, 900. Now, we'll send over a 900 here. It's a very strong 900 coming. There it is. Pretty close. But I am pounding us. You know what? Also, I'm sending the signal in rather inappropriately into here. We don't want to do that. Volume down, power down. We want it to go into the antenna. So now hooking it up here, a signal generator with a low impedance may throw the radio off, and you cannot tell because every time you connect it, the radio is throwing off, and it's just always in this throwing off condition. And no matter what you do, you will go crazy. So I'm going to use a I think I'll try capacitor's it's a big capacitor. Here we are. This will work a little better. Got a resistor here and a capacitor. And that'll just imitate the antenna a little bit. The antenna, this wire, when stretched out, looks like 300 ohms or so to the radio at radio frequency. Signal generator is 50 ohms. Stick this in here, now it's more like an antenna to the radio. Radio doesn't know it's hooked up to an old military box. Put that over there. Like I say, I may have to cut this off to reduce the interference pickup. Turn this up. There's the 900. 895 when the capacitor is straight up. Now we're tuning. Well, there's no tuning here. So this will be the oscillator. Let's check it. So I'm trying to interfere with the stator plates and cause the local oscillator to swing a little bit, and that'll cause the radio to sound like it's being tuned in and out. If I do the other one, what it should do is it should just kill the radio. Wait a minute, a light touch and it gets better. This radio's plugged in a regular outlet. I checked it when I plugged it in. I used a voltmeter to make sure there's no voltage on the chassis. I'm being careful what I'm doing with my other hand. I'm pretty sure this has to be the oscillator here. So the only reason to adjust this he says very hesitantly. Let's adjust it a little bit and see what happens. This basically is adjusting. There isn't. You can't say basically. There's no basic here. Oh, just jumped. It's sticky. A lot of these screws, when you try to turn them, and instead of moving smoothly, they'll jump. And that's a problem. Let me take this big honking metal screwdriver, check it for sensitivity. Doesn't seem to do anything to the radio. This will give me tremendous control over that screw. I am in charge. If the screwdriver stays in. And we're going to tune the radio a little bit this way, a little bit that way, and check to see if there's a better spot, a sweeter spot. Just a little this way. Just a little. Oh my gosh, I can't. Okay, so this thing's jumping. So I'm going to put the knob back on it so I have better control over it. I could also lubricate it. That would help things out. Should put this knob on so it matches the capacitor. And then it'll match the dial too. Okay, now I got much better control over it. Guess that's where I want to go and just see. Try different positions here. First of all, the loudest spot. Move the oscillator a little bit. Doesn't sound louder to me. Now this really should be done with a meter. That sounds louder. It's definitely a sweet spot in here. Really what's actually happening here is I'm aligning three things by moving two of them. I won't say what they are because I don't know. This is still hard to do here. Let's give it a little lubrication. Okay, so ball bearings. And then there's a grounding spring. Just a teeny tiny bit. It's more than teeny tiny. And then the point bearing on the back. Ooh, piled in a lot. That'll make it easier to do. Okay. Yeah, I have to get out the voltmeter and really an indicating meter to show the signal level. But let's just keep going here. Right in here somewhere. Not a lot of difference. Okay, we're going to take this down. We're going to set this to be receiving 590. Oh boy. Okay. 590. Oh, I just happened to tune the radio right on it. Okay, so this is 590. Radio's now receiving 590. Let's tune it in better if we can. There could be another adjustment I'm currently not aware of. But we'll leave it like that. question is, can we actually pick up 590? The strongest AM station around here is 590. There is no station around here. So 590 is the strongest station. Hook up the outdoor antenna, see what we hear. Ground on. Antenna. And that's what we hear. Nothing but that. Wow. Just, whoops, that's not. Tune it just a little bit because it's right on the money right now. We just can't overcome this interference that's coming through. So whenever I hook up the ground, so let's take the ground off. It's not much better, is it? Change the pitch of it. It's not, you can't hear anything over it. So these radios have most of these anyway, have an automatic volume control system in it. And if there's a strong station being received, the radio's sensitivity is brought way down. And in the end, what it sounds like to you is every station sounds about the same volume. One of the problems with that, by the way, is when you tune between stations, the radio sensitivity goes way up and you hear the rush, coming out. It's very annoying to tune between stations because the radio sensitivity goes right through the roof. With the noise signal here, this radio's level control will automatically quiet the radio down, so the interference signal becomes quieter. I mean, the radio thinks it's a radio station, but of course it's not. But in bringing down the sensitivity of the radio, it makes the radio unable to hear real radio stations, which are much weaker than this noise signal. So all we get is just this noise, and it sounds like there's nothing else going on back there. If I turn the radio way up and tolerate this noise, I might hear in the background the radio station I'm after. But that's a big maybe. So what do we do about that? The radio has to go to another location out of the house here to see if it even operates properly. Well, that's a good time for me to stop and enjoy some more coffee, and I'll do that experiment. We'll see what happens. At least I'll see what happens. Okay, I mentioned earlier I don't like to talk about safety and that. That's really, if you're doing this kind of work, your safety is your business, not mine. But let me show you something here. So earlier I checked the chassis to see if there's any voltage on it. I have the radio plugged into a regular outlet. I reversed the plug and I got no voltage. One way I got 120 volts, the other way I got nothing. So let's see which way it is right now. Should be the nothing way. Make sure you kind of see what I'm up to here. So one lead, AC volts, one lead on the chassis, other lead onto a grounded point is 0. Well, that's safe. Surely to goodness, if you turn it off, it's even safer now, wouldn't it be? I mean, I turned it off. Wouldn't it be safer? And there it is. That's the whole hot chassis deal. That one way it looks good and turn the radio off. Now if I reverse the plug, I'll get the reverse effect on the radio. So it doesn't matter which way you plug it in the wall. What matters is which way you plug it in the wall and which way the on-off switch is. Now, this is not a hot chassis radio. I would call this a warm chassis radio. But in other radios, it's a truly hot chassis. And so if you think, well, as long as I turn it off, it should be safe. No. That's the part of the hot chassis situation that is so confusing to people. How can that be? Well, if you look at it long enough and study it and read enough stuff, you don't have to read a lot, you'll find out exactly why that's the case. So I'm going to unplug this guy. And notice too, that as I turn the radio off, what am I doing? I'm holding on to the metal knob. So the moment the radio went off, 120 volts appeared on here. Or did it? Maybe not on the shaft here. But I'm not going to look and find out. I'm going to take this radio out into my garage and I will report back what I get. Okay, quick trip out to my garage, plug the radio in, plugged it in this way and that way, and the result is exactly the same. That same ticking noise is overwhelming this radio. Couldn't receive a thing out there except the ticking noise. Now I haven't stretched the antenna out. I don't think it's worth even trying. So like the last radio I worked on here was a great big communications receiver, a Hallicrafters communications receiver with 7 or 8 tubes in it. It had many more stages of tuning. And the advantage of this is noises like the one we're fighting with here tend to get suppressed more and more and more, and you end up hearing more and more of what you're tuning into. So this guy, he just doesn't have the wherewithal to operate in the modern world. That's kind of where it's at with this radio. And anything like this. Most 5-tube radios are really going to struggle. Now what makes this one particularly bad is this wire antenna. So you get a lot of these older, smaller 5-tube radios, and there's a loop antenna on the back of the radio. Here's one to look at. Here's one like that. So this is part of the tuning system. This is a carefully constructed coil. It's matching up with components in the radio, not this radio, but the radio this came from. And that in itself forms a bit of the tuning of the radio, and it's already helping with interfering noises and other stuff. So this guy's just got a wire. He's just got a wire. He's hopeless. That's what it would amount to. So, but somebody did do all that work. This is not plugged in, right, Jim? Yeah, not plugged in. Somebody did do all that fine work under there. I just wonder if in the end they were quite disappointed with the result. You might say, oh, put the metal cabinet back on it, and that'll solve all those noises. No, it won't. So that's about all I can do with this radio. This is a one-day deal on this guy. I can't do any more with it. Would there be a tube implicated in this problem? No, I don't think so. I think the radio's operation proves the tubes are functioning fine. So that's it. That's the end of the road for this radio, unfortunately. Not the end of the road. The radio is what it is. It is doing what it's supposed to do, probably working pretty much exactly as it did when it was new, or very, very close. We just can't expect any better performance out of it. If I took this further from my house, you got to power it with an extension cord. So some of your house is coming along in the extension cord, but if I got this far enough away, out in my backyard or up on my deck, might be able to pick some stuff up. Stretch this antenna out, try to stretch it out where there's no noise source. Don't know what the noise source is, but just away from the house, away from any power wires, or away from everything. Maybe this guy would work. But right now, there's almost 3 feet of snow. It's waist deep. Snow is waist deep on my deck. I don't think I'm going to go out there and try it. So that's it. That's it for today. That's it for this radio. I'm just going to put the cabinet back together and return it to my buddy and tell him there ain't nothing wrong with this radio other than it's kind of junky. So thanks a lot for watching, and I'll have another radio in here tomorrow. See ya.